morning students. Today we are going to discuss about acceleration due to gravity and freely falling body and its applications. Right. What is acceleration due to gravity? It is nothing but what? The uniform acceleration of a freely falling body towards the center of the earth by uniform acceleration of a freely falling body towards the center of the earth due to Earth's gravitational force. Is called acceleration due to gravity. So what is this? Uniform acceleration of a freely falling body towards the center of the earth due to Earth's gravitational force. That is called what? Acceleration due to gravity. So that means here this is the surface of the earth. Here a body is there, the body is freely drawn. So it is attracting, it is pulling by the earth. It is pulling by the earth with some gravitational force, and that gravitational force, due to that gravitational force, it acquires some uniform acceleration, and that uniform acceleration is called acceleration due to gravity, and that is represented with small g. So acceleration due to gravity on the surface of the earth, average value on the surface of earth, this is what average value, there is 9.8 meter per second square. So this is always towards the center of the earth. So it's a vector quantity. It's a vector quantity. It is always acts towards center of the earth. Towards the center of the earth. Right. The G value is different at different places, even on the surface of the earth also. You see here, if you observe that acceleration due to gravity at the poles and the equators, they are not same. So at poles you can observe that the acceleration due to gravity is maximum. G is maximum at poles. At poles, that is around 9.83. That is 9.83 meter per second square. That is at poles. And G is minimum at equator. And that is 9.78 meter per second square. So average value on the surface of the earth, this is the average value. When we are solving the problems, we take this 9.8 meter per second square is the value for solving it. Right. Next. See, the G value depends on place to place how it is varying means that depends on some factors, like if there is any place that place is containing some mines, some group of buildings, so that and all is present. Due to that acceleration due to gravity will change. And one more thing, acceleration due to gravity on the surface of the earth is 9.8, and that is different for different planets. You see here, if you take the acceleration due to gravity on moon surface, that is the value what is there on the earth's surface by 1/6 of the value which is there on the surface of the earth will be on moon surface, and that is equal to around 1.67 meter per second square is the value on the moon surface. Right? So like that, so that is different for different planets. So that depends on acceleration due to gravity for different planets, depends on the mass of the planet. Okay, so that depends on mass of the planet and radius of the planet. So depends on that small g will vary. This and all we can discuss detailedly in gravitation chapter. Okay, right, next. Now this is about the acceleration due to gravity. Now see here, we go for freely falling body. Next condition. And before discussing about that, one more some important point is there for gravitation, acceleration due to gravity, and that is same for all the bodies on the surface of the earth. If you take a small body or a big body, whatever it is, on all the bodies, the acceleration due to gravity at a particular place will act same only. So that does not depend on size of the body or shape of the body, or that does not whether the body is hollow body or solid body, or that doesn't mean. So whatever the changes, whatever the body you take, so for all the bodies you will observe that acceleration due to gravity is 9.8 meter per second square. That is the average value of the surface of the earth. At a particular place you are noticing that is 9.8 meter per second square. You are noticing that goals means that is 9.8 for all, 9.83 for all the bodies on the surface of the earth. Okay, so one more thing. See here, if you observe the weight of the body at the surface of the earth, on the surface of the earth, if you observe the weight of the body is suppose 60 kilogram weight, 16 Newton, then what is the force on the moon surface? What is the force on the moon surface? That is 1/6 of its force. Okay, weight. So weight on surface of the earth, weight on earth is equal to suppose 16 Newton is acting. Means on the surface of moon, that is 1/6 of the weight on earth. So that means what you can notice, weight on earth is equal to, so 16 Newton, 60 by 6, so you get 10 Newton. So what is this? So weight on moon is 10 Newton, weight on earth is 60 Newtons. But what is changing and what is not changing is, so here we observe a body, the same body I am taking even onto the moon surface also, mass of the body remains constant. Here, whatever the mass of the body is there, the same mass only even I have taken even onto the moon surface also. Mass of the body will not change from planet to planet, but due to acceleration, due to gravity, the weight of the object on Earth planet and the moon planet is varying due to acceleration due to gravity only, not due to the mass of the body. Okay, so that is what one important point you should notice. Okay. So weight will change from place to place since acceleration due to gravity will change. Since weight means what? Weight is the product of mass into acceleration due to gravity. So mass of the body remains same, but acceleration due to gravity it changes from place to place. Here on the surface of the earth we are taking g, and on the surface of moon we are taking g by 6. So due to that g by 6, here mg by 6 it is coming. So here mg is 16 Newton, means here mg is 60 by 6. So 10 Newton came. So like that you can say. Okay. The next freely falling body. So what is freely falling body? If a body is dropped from a particular height, so you can notice that initial velocity is 0. While it is coming downward direction, a is equal to plus g here. So while it is coming downward in plus g it is coming means at what speed it hits, and what are the we can apply equations of motion for this. What are the how it changes velocity. So first equation, you know that v is equal to u plus at is the equation of motion. First equation of motion. So if v is hitting with the velocity v after a time t seconds, then what is the velocity with which it hits the ground? So that is what we need to calculate. So v is equal to u is 0 plus a is g. So v is equal to gt. So we have first equation of motion for freely falling body. It converts like this. So with what speed it hits the ground means v equal to gt speed it hits the ground. Next, second thing, s equal to ut plus half a square. Second equation, s equal to ut plus half a square. Suppose a body is traveling to a distance s. Okay, so s equal to h equal to u is what? 0. You apply 0 into t plus half while it is coming downward gt square. So h is equal to half gt square. From this you can calculate what is the time it takes to reach the ground from a body for a body which is dropped from a height h. So that means t is equal to, from this you see here, t square equal to 2h by z. From this t equal to root 2h by z. So that means this is the time it takes to reach the ground. Okay, if it is dropped from a height h, right? Next, go to third equation of motion. Third one, what? From v square minus v square equal to 2as. So v, with what it is sitting, it is v. But v is 0. So v square minus v square equal to 2as is h. Suppose it is traveling from this to here, s is equal to h means v square minus 0 square equal to 2gh. So v square equal to 2gh. From this v is equal to root 2gh. So with that speed it hits the ground. So here, if you know distance, height, and time is not known, then what is the speed with which it hits is v equal to root 2gh. If you know time means v equal to gt, you can calculate. If you don't know time means, if you know only h means, you can use this formula. V equal to root 2gh. That is the velocity with which it hits the ground. Next, another one. So Sn equal to u plus a into u plus a by 2 into 2n minus 1. Right? So this is the distance covered in a particular nth second. So Sn is equal to u is 0 plus a is equal to g by 2 into 2n minus 1. So from this what you can write Sn equal to g by 2 into 2n minus 1. Here g is a constant and g by 2 is also constant. Sn is directly proportional to 2n minus 1 is the relation between distance covered in a second. Like this you can write. See here in the previous case you observed it. Here h is directly proportional, h is equal to half gt square. From this if you take s, h is s means you can write no problem. So half gt square. So that is not the distance, complete distance covered during the time t seconds. So half g is also constant. S is directly proportional to t square. S is directly proportional to t square. T is the total time of journey. And s is the total journey distance covered in particular downward direction. Okay, here distance covered in a particular nth second is directly proportional to 2n minus 1. Suppose you see here, if a body is dropped from a particular height, the body is dropped from a particular height, u is equal to 0. Distance covered, ratio of distance covered. Suppose it is taken some time to reach the ground. In first second, next first 2 seconds, next first 3 seconds, this is first 2 seconds, this is first 3 seconds, like this it is reaching. Now, so next first 4 seconds, here suppose 4 seconds, first 4 seconds, first 3 seconds, first 2 seconds. That means only 2 seconds. This is first second means this is first second alone. This is first 2 seconds means complete first second plus second together is first 2 seconds. Next, first 3 seconds means first second, second second, third second, all together is first 3 seconds. So like that we are taking. So this is what in first second distance covered is what? Yes, one like what you can say distance. It is just like some distance it is covered as 1, and inside the first 2 seconds distance covered is like as 2 seconds, and then in first 3 seconds let it be as 3 seconds, and in 4 seconds let it be as 4 seconds, like that, and seconds are there to reach the ground. So that means in that situation, so distance covered in the whole time is directly proportional to t square. So based on this, s in 1 second is to s in 2 seconds is to s in 3 seconds is so on is equal to first 1 second square of the time. So first second square, next first 2 seconds. So 2 square, next 3 square, 4 square, and so on. So that means 1 is to 4 is to 9 is to 16 is to so on. Some of this that is what ratio of the squares. That is what ratio of distances covered in first second, first 2 seconds, first 3 seconds. Like that. What is this? Ratio of distance. This is what ratio of distances covered in the first second, first 2 seconds, first 3 seconds, and so on. This is the ratio. Okay. Next, similarly, you can go for another one. Suppose the same case, body is drawn from a particular initial velocity is 0, where it is falling down. Ratio of distance covered in first second. Next, after first second, this is what second second, second second. This is first second. Next, after this is what third second. In this second, first second, let S1 be the distance covered. In second second, let S2 be the distance covered. In third second, let S3 be the distance covered. And so on. Suppose it is sometime it takes to fall down. So then the ratio of them is equal to Sn is directly proportional to 2n minus 1. So you know that what is this Sn is that S1 is to S2 is to S3 is to so on Sn for n seconds. So what you can write so on is equal to 2 into S is 1 second. So 2 into 1 minus 1 is to 2 into 2 minus 1. That is second case. Is to 2 into 3 minus 1. So on like this. Okay, so what is this? 2 into 1 is 2, 2 minus 1 is 1. Is to 2 into 2 is 4 minus 1 is 3. Is to 2 into 3, 6 minus 1 is 5. So on 7. So on odd numbers ratio will give you the ratio of distances covered in first second, second second, and third second, and so on. Right? That is one ratio of distance covered in first second, second second, third second. Like this. This is the ratio of distances covered in first second and first 2 seconds, first 3 seconds, first 4 seconds, like this. That is all together. This is only particular second. So this is the whole ratio of the distances covered in nth second. Right? Next. The fraction of distance covered in a particular nth second. Fraction of distance covered. Fraction of distance. Covered in nth second is Sn by S is equal to what? We are getting Sn is equal to A by 2, G by 2 into Tn minus 1 for a freely falling body. For a freely falling body. For a freely falling body, fraction of distance covered in nth second. So Sn form G by 2 into Tn minus 1 by half G n square for n seconds. So half G n square, half G gets cancelled. So we get Sn by S is equal to 2n minus 1 by n square. So this is what the fraction of distance covered in nth second for a freely falling body. So based on this, some problems will be asked. Suppose if the fraction of distance covered is equal to given like 9 by 25 is given. Then what is total number of seconds? So 9 by 25 means we take n is equal to 5 means 2 into 5 minus 1, this is 9 and this is 5 square. So n is equal to 5. So n equal to 5 means total journey time is 5 seconds. Okay, so from this you can calculate for freely falling body what is the total distance covered with the answer. Yes, total distance covered is equal to during that 5 seconds for a freely falling body ut plus half a square. U is 0, so t plus half a. A is what? Freely falling body, so g into t square. T is what? N, so 5 square. Okay, so 1 by 2 into g, if you take 10, that is 25. So 2 1s are 2 5s are, so 125 meter. It is the distance covered in a total distance covered. So like this they can ask the question. Okay, so suppose 2n minus 1 is given, like sometimes percentage also they may ask. So 2% 2.2 fraction of distance given, a percentage of distance covered in a particular second is, suppose you got 9 by 25. What is the percentage you want to convert? So here if you multiply by 4 and 4, divide by 4, 9 4s are 36 by 100. Nothing but 36% of distance is covered in that 5th second for a freely falling body, right? So like this you can calculate this, right? Next, go to another. Freely falling body is equal to 0. In suppose mth second, distance covered is equal to Sm. In nth second, distance covered is Sn. Then acceleration due to gravity. Here no need to calculate the acceleration due to gravity. Suppose if it is in horizontal direction, then acceleration to calculate will use that. Suppose in nth second that is Sm, in nth second that is Sn. Then acceleration to calculate Sm minus Sn by m minus n. That formula will use. So that is not needed here. Just leave it. Right, next go to another one. See that next step. Here there is a tower. From this tower, a body is dropped, initial velocity is equal to 0. Suppose if it takes a time t1 seconds to reach the ground, and second body is dropped from there with an initial velocity 0 only. While it is coming downward, somewhere somebody hold the object. So during that holding, so journey time from here to reach that will be t2 seconds. After traveling t2 seconds while it is coming in downward direction, after traveling t2 seconds, so to reach the ground, if it takes further t3 seconds, means what is the extra time taken, what is the relation between them. So that is what we need to calculate. If it is stopped for a moment, means final velocity somewhere you hold it means hold again releasing means for next case that is initial velocity 0. So but if you observe in all the cases, this case and this together is total height or distance covered by the bodies. This case and some of these two cases will be same. Suppose this is the height h1 means for here distance covered that is h2, here h1 is equal to h2 plus h3. So here h1 is what will be falling body, so half g t1 square only you can write. Since ut plus half h square u0, so half g t1 square is equal to h2. h2 is what this is the distance covered. It is also started from rest. So what you can write ut plus half at square you can write. h2 is equal to ut plus half at square. So u is equal to 0 here also u2. So this term becomes 0. So again we get half at square only, that is h2. A is what by coming downward, a equal to g. So h2 is half g. What is the time taken during the h2 is t2 seconds. So half g t2 square. Plus for third case, if it is taking t3 seconds to travel that h3 distance, then half g into t3 square. Since even third case also started from rest only. After holding, releasing. So initial velocity is 0 even here also. So if you observe half g common cancel, you get 2 square equal to t2 square plus t3 square. So if you really wanted to find t3 means third second, how much you need to calculate? t2 square equal to t1 square minus t2 square. t3 is equal to root over t1 square minus t2 square. That is the time it takes to travel further to reach the ground. Okay. Suppose if you take one body is dropped from a particular height, it takes a time of 5 seconds for a freely falling body. For first case t1 is given 5 seconds. So later after this this is completely journey, it takes 5 seconds. Now see here, next case, if it is traveled after traveling 3 seconds, if it is dropped, if it is folded after traveling T2 is suppose 3 seconds. After 3 seconds, the object is hold here. Again release means that will further how much time it takes to travel. So that means what they are asking T3 is what they are asking. So how to calculate the T3? You know, this is the formula. So what is that? T3 is equal to, or you can say that T1 square equal to T2 square plus T3 square. T1 square equal to T2 square plus T3 square. You know that T1 is equal to 5 square. 5 square equal to T2 is 3 square plus T3 square. Next, see here 25, 5 square is 25, you send this 3 square is 9, left side, so you get T3 square. So 25 minus 9 is 16 is T3 square. So after this, T3 will be equal to plus or minus 4 seconds. So you can't get here, T3 will be, you can take only plus 4 seconds. This is correct. So time cannot be negative. So minus 4 seconds is not possible. So time cannot be negative. So that is what you have to notice. The case. Time cannot be negative. So time can be only positive. Right? So plus or minus 4 seconds is not answer. Time can be only positive value. That is an application you can say for this. Right. Next. Go to another application. There is a multi-story building. So from this multi-story building, a body is dropped. U is equal to 0. While it is reaching in its path, there you notice the point A and another point B. While it is crossing that point A, if it takes a time t1 seconds, and while it is crossing the point B, it takes t2 seconds. Then what is the distance between A to B that you need to calculate? Distance between A to B I need to calculate. So how to calculate is, you see here, distance between A to B means distance of that B minus distance for A. You need to subtract. From this full distance, if you subtract this, you get this. Okay, so what is this? This is a freely falling body. So freely falling body means height to reach the point B is equal to half gt square generation. S equal to ut plus half at square. S equal to ut plus half at square. Here what is u? 0. For t2 also 0, for t1 also 0. So what is this? HA if you want to calculate, u is 0 into t is for t1 plus half a is g t1 square. So that is HA is equal to half gt1 square. Similarly, what is HB? HB is also equal to ut plus half at square formula. So 0 into t2 plus half g into t2 square. So height of B is equal to half g2 square. So this is a height distance covered for the point B, and this is the distance covered for the point A. So distance covered from up to B minus distance covered up to A, if you subtract, you will get that. So half G into B is what? T2 square minus T1 square. So that is what the distance between A to B. Okay, so right, next. Suppose instead of given times, if they have given distances, like this is H1 and this is H2. It is just like, you see here. Here there is a multi-story building. So body is dropped, so U is equal to 0. While it is reaching the point, there are 2 points like in the previous case, A and B. So A is at a height of H1. B is from the ground, from the top point, that is distance covered is equal to reach the point A from the top of the multi-story building is H1. To reach the point B from the top of the multi-story building, that is H2. Then the distance between A and B in terms of given quantities. So time is not given. So now we need to calculate in terms of heights. Okay, so right. And one more thing, see here, heights means you can say directly H2 minus H1, you can say. Suppose, what is the time taken to reach from A to B? If they ask. Time taken to reach from A to B, if they ask. then what you need to do? So time taken to reach B minus time taken to reach A, you should calculate. So time taken from A to B you need to calculate means time taken to reach the point B minus time taken to reach the point A, you get the time taken between A to B. Okay, so what is this time taken? They have given further to calculate. Suppose if it is t1 seconds. So how can I calculate? T is equal to root 2h by z. General formula. Time taken to reach this is equal to root 2h by z. T1 in h1 is h. Okay, similarly, what is this? To reach this point B, T2 is equal to root 2h2 by z. So you need to calculate time for A to B means total time to reach B minus time taken to reach A. You get the time taken to reach A to B. Okay, so time taken, what is this? Root 2h2 by A minus 2h2 by G minus root 2h1 by G. So you can write root 2 by G is common. Root h2 minus root h1 also you can write. That is the time taken to reach from A to B. This is the next case. See, another. Suppose you see next case. Here, from certain height, a body is dropped with an initial velocity u is equal to 0. So it is dropped after some time. Let it be, if it is dropped after that t seconds, if another body is dropped, okay, after t seconds, first body, one body is dropped, initial velocity is 0. So let it be covered distance, let it be h1. After t seconds, another body is dropped down. So the second body will follow this first body. So while when the first body, second body is ready to release means first body would have gone somewhere else. Okay, so then the gap between them at the time of releasing whatever you are feeding, the same will be maintained throughout its journey, anywhere if you take. So that means h1 difference h2, h1 minus h2 will be the difference throughout its journey any instant. So that is what the next application. Okay, see here I repeat that if the first body is dropped, if there are two bodies, first body is dropped, after dropping some time you are dropping second body. At the time of second body dropping, already first body is travelled some distance. Whatever the distance you are noticing between the second body dropping position to the first body travelled position, so the same distance will be maintained until they reach the ground, anywhere. First body reaches the ground. Okay, so the same separation will be maintained because on both the bodies will have the same acceleration gravity. So the separation is maintained until the first body reaches the ground. Okay, so that is what that is another application. Next. So gravity will be same on all bodies. So to say that is what we are observing. Right? Next. Go to next one more condition. Suppose here one body, first body is dropped. Here is equal to 0 from certain height. From a particular level, here one body is dropped. Second body is thrown down from the same point after some time, after some distance. Suppose you see here first body is dropped. If it takes some time to reach the ground, so distance covered is equal to, suppose h1 is equal to distance covered after time t seconds. h1 is the first body covered distance. h1 is equal to ut plus half at square. U is what? 0, u1. So half g t square. Suppose if it takes t seconds to travel. After t seconds, after some x seconds, so first body is dropped. After dropping x seconds, after dropping the first body, x seconds after second body is thrown down with an initial velocity of u2 is equal to u. First body is dropped after x seconds. After x seconds, second body is thrown downward with an initial velocity u. Suppose while it is going in its path, the second body is thrown downward. Then, if these two are going to meet at one point, so if these two are going to meet means that means side by side only to show the difference and making the same. So if the both of them meet at the same height, so what is the distance covered? You need to what is the condition for it? You need to calculate. Okay. So for freely falling body, suppose after a time you just assume the first body is dropped after a time t seconds. Suppose both the bodies are meeting means. So during that time, first body covers a distance of half gt square. Okay. Second body is thrown downward. So second body is thrown downward. Its initial velocity is not 0. So that is u2t plus half gt square. Okay. So but here t2 is what? T2 is given for second body after x seconds of first body is dropped. So that means if both of them are meeting at t seconds means t minus x seconds will be the traveling time for second body. Okay. Suppose if it takes 10 seconds to travel. If for a freely falling body 10th second a second body is thrown down after 3 seconds or after 2 or 3 seconds. Suppose after 3 seconds, second body is thrown down. So, if both the bodies are meeting means the journey time for the second body will be journey time for the first body minus dropping time gap. Okay. So that means suppose I repeat, if it takes 10 seconds to meet the second body which is coming behind. After 2 seconds, if I drop means, if I throw the second body, after 2 seconds of first body thrown means, then journey time for the second body will be 8 seconds only. So, since 10 seconds, after 2 seconds I drop. So, 10 minus 2, 8 seconds will be the journey time for the second body which is thrown downward. So, that case. So, okay, what is u2? U. What is t2 for second case? T minus x plus half g into t minus x whole square. Correct? So that is what half g into t square. T is what? T2 is what? T minus x whole square. Right. So this is h. If both of them are meeting means what is the condition? h1 should be equal to h2. Then only they will meet. So you can equate half gt square is equal to u into t minus x plus half g into t minus x whole square. This is the condition to meet both the bodies. One body is dropped body, after x seconds, second body is thrown down means both of them will meet. This is the condition. First body covered distance should be equal to second body covered distance during t minus x seconds. So both are equating. So after equating you get the condition. Okay, so you will simplify you get times. Okay, so that is the condition to solve the. Okay, that's all for today. So in the next class we will see about vertically projected model. Thank you.